Good afternoon, students. I am Basov sir. Today I am discussing about a important problem on moment of inertia. The problem is about T section. So in your syllabus there are T section, I section, channel section, and angle section. So the method of all this type of problem is almost same. So if we understand the method of one problem like T section, then we can understand the other problem like I section, channel section, angle section easily. Okay, so let us do the problem. The first see the problem. The problem is find the moment of inertia of a T section with flange as 150 mm into 50 mm and wave as 150 mm into 50 mm about x and y axis to the center of gravity of the section. So here the T section is given. There are two parts of a T section. This is called flange and this rectangle section, and this part is called wave. Okay. So we have to find out the MI. At first we have to find out the CG of the two sections. Okay. Then we find out the MI of the each section, and then the summation of the two MI of these two sections will be the actual answer or actual MI. So let us find out the CG of the two sections. At first, for CG of the first section, we have to determine the area of the first figure. That is area of figure 1. Area of 1. That is A1 equal to, what will be the figure? Figure will be is 150. 150 into 50. Okay, equal to will be as 7500 mm square. Okay. Now therefore the CG of the figure. What will be the CG? This figure is actually symmetrical about y-axis. That is y-axis. So the x coordinate is 0. That is the CG of this figure, CG of this figure, and the CG of total figure. The x coordinate will be 0. So only y coordinate is present. So for the first figure, the CG will be, that is y1 will be as 150 plus 50 by 2, because actually we are taking this line, that is the flange, the baseline of the wave is the reference line. So we have to consider the length or coordinate from this line, Okay. So from this line, the CG of this figure will be as this length, that is 150 mm plus the total length is 50. This portion is 50 mm. So CG of y coordinate of that is CG distance of CG from this line will be half of this. So this will be equal to as 175 mm. Now for rectangle 2, that is area of 2. A2 will be equal to, what is the value of A2? A2 will be equal to 150 into 50. That is, it will be equal to same value 7500 mm square. And for this figure, y2 will be as, y2 will be only this. This is actually figure A2. So y2 will be this total length is 150. So y2 will be the half of this length. That is 150 by 2 equal to 75 mm. Okay. So y2 is 75 mm. Now we know that distance between center of gravity of section and bottom of the wave, that is the actual distance of the CG, that is the distance between actual CG of the total figure and the bottom line will be as this will be called y bar, and this will be added as, this is the formula, a1 y1 plus a2 y2 by a1 plus a2. This is the formula. If there are more than one figure, then the actual CG, formula of the CG, distance of the CG of the total figure from the reference line is follows this formula, y bar equal to a1 plus a2 y2 by a1 plus a2. And putting the value of this, putting the values in this formula, we can get y bar equal to 7500 into 175 plus 7500 into 75, because y2 is 75, y1 is 175. By y1 plus a2, a1 plus a2 equal to 7500 plus 7500. The value will be as, calculating the value will be as 125 mm. So y bar equal to 125 mm. That is actually the coordinate of CG will be 0, 125, because y coordinate is 0. Now, moment of inertia about x-axis. So, we also know that moment of inertia of the first figure about an axis through the center of gravity and parallel to x-axis. That is, we know that moment of inertia of the first figure about the center of gravity and parallel to x-axis will be as I g1 equal to, this will be equal to as the moment of inertia of this figure about the CG of this figure, and parallel to x-axis will be as Ig1, that is formula is actually Ig. So here there is two figures, so that we can take Ig1. So Ig1 equal to BDQ by 12, as this is a rectangle. So here B means 150, D means 50, so BDQ 50 by 12, and calculating we can get the value is as 1.5625 into 10 to the 6. It was 6 mm to the power 4, and here the distance between the center of gravity of the rectangle 1 and x-axis. Actually, x-axis is going through the actual CG of the total figure. So it is going almost in this direction. So and the CG of this figure lies in this line, and here any one point of this position. So the distance from the CG of this section to the actual distance of the CG will be as this is the distance from this line to this is as 175. We calculate it earlier, and the distance between this to this line to this line is 175. So, and the distance of the CG we can get as 125. So distance of CG from this line is 125, and distance from this point that is CG, and this line is 175. So the distance from this point to this point is 175 minus 125. Therefore, H1 equal to 175 minus 125 equal to 50 mm. Okay. Now, so the momentum ratio of the earlier we get that momentum ratio of that of this figure about CG is this, and momentum ratio of any other axis, that is parallel to x axis, will be as about x axis will be as Ig1 plus A1 H1 square equal to putting the value 1.5625 into 10 to the power 6 plus value of A1 is, what is the value of A1? A1 value is 7500 into H1 is 50, so 50 square. So this is the momentum inertia of the first figure, this is total one about x axis, and the value is equal to 20.3125. E125 into 10 to the power 6 mm to the power 4. Similarly, we can get the momentum ratio of the second figure, that is figure 2. Similarly, we can get Ig2 as Ig2 equal to 50 into 150. Here B is 50 and D is 150. So B dq by 12. So the value, calculating the value, Ig2 is as 14.0625. 14.0625 and 6 mm to the power 4. And similarly, the distance of the actual CG and the CG of this figure will be as, distance of the actual CG from this line is, we can get 125, and distance of the CG of this figure is 75. So distance of the CG of the actual figure and distance of CG of this figure, that is distance CG may be in this point, and actual CG will be like in this point. So distance of this CG of total figure and the distance of the distance of the CG of this figure difference will be called as H2 equal to 125 minus 75 equal to 50 mm. So now we can similarly like first figure, the momentum inertia of the second figure, momentum inertia of the second figure about x axis will be as Ig2 plus A2 H2 square equal to 14.000625 into 10 to the power 6. This is Ig2 plus A2 is as What is the value of A2? It is 7500 and H2 is 750, so into 50 square, and calculating the value will be as 32.8125 into 10^6 mm to the power 4. So this is the MI of the second figure about x axis. Now the MI of the total figure will be the summation of MI of first figure and summation of MI of second figure and MI of second figure. So the moment mass of the whole section will be as about x axis I x6 equal to 20 into 20.3125 into 6 into 10 to the power 6 plus 32.8125. Equal to 53.125 into 10 to the power 6 m to the power 4. Now this is moment of inertia about x-axis. Now moment of inertia about y-axis. So moment of inertia about y-axis, that is moment of inertia of the first section, section 1 about y-axis will be as, it is simply as the figure is that both the two figure and the total figure is symmetrical on y-axis, therefore moment of inertia about y-axis is very easy. It will be as moment of inertia of first figure about y-axis will be as equal to 50 into BD, 1 to BDQ, 50 D, 1 to dBQ, according to formula. Moment of inertia about y-axis is 1 to dBQ. So this is D of the first figure and this is B. 150 Q by 12. Value is 14.0625. 14.0625 into 14.0625 into 10 to the 6 and to the 4 into 6 and to the power 4. And moment of inertia of the second figure. Moment of inertia of the second figure will be about that is figure 2 about y-axis will be as 120 dBq. Here D is 50. Sorry, and D is 150 into 52. 150 into 52 equal to 1.5 1.5625 into 6 mm to the power 4. And now the moment of inertia of total figure about y-axis will be the summation of these two equal to, that is I y. Moment of inertia of the total figure about y-axis I y equal to summation of 2, that is 0625 10 to the 6 plus 1.5625 that's 6 equal to 15.625 15.06 into 4. So this is the answer. 6 into 4. So this is the process to find out the MI of T section, and for I section this is also same. I section, channel section, all the processes are almost same.